So today we are going to talk about the distance formula, and what I really want you guys to understand is that this is not a new formula, but a formula that is derived and comes from the Pythagorean theorem. So let's go ahead and start by opening our spirals to a new page, and at the top of your page write the title of your notes at the top of your page, which is distance formula. So to begin, we can use the Pythagorean theorem to find distance between 2 points on a coordinate plane. The diagonal distance can be thought of as the hypotenuse. And we'll look at this in a minute because I'm going to show you a picture that will help this make more sense. So if I have 2 points on a coordinate plane and I draw a line between those 2 points, that distance on a diagonal is the same as the hypotenuse using your Pythagorean theorem. So then we have to be able to find the two legs, which would be the horizontal change. So that's the change left to right. That's one leg. And then it would also be your vertical change, your change up and down. That would be your other leg. So to find your horizontal change, you have to take one x value and subtract another x value. And to find your vertical change, you take your y values and subtract your y, because your y is your vertical axis and your x is your horizontal axis. So remember, subtract your x values because your x is your horizontal line. Subtract your y values because your y is your vertical line. Now, I think when I show you an example on the coordinate plane, this will make a little bit more sense. So we're going to look at that in a minute, but before we do that, let's pause the video and write everything on this slide into your notes. It's all very, very important. So let's pause the video now and copy this into our notes. So let's take a look at an example. Here you see we have 2 points, and let's go ahead and write the ordered pair for each point. You have point 1. You have point 1, we'll call that P1. And the ordered pair for P1 is over 1, 2, up 8. So we have 2, 8. And then we have point 2, P2. And the ordered pair for that is over 7, up 3. So if we look at this, hopefully you guys see that it kind of looks like this diagonal line looks like a hypotenuse on a right triangle. We've got that diagonal. So what we have to do is we have to find out the horizontal and the vertical change. And there's 2 ways to do that. If you have a coordinate plane, you can just count the distance, 1, 2, 3, 4, 5. That is your horizontal change. Or you can do what we said on the previous slide. You can find the difference between your x's and your y's for your vertical. So this is x and this is y. This is x and this is y. So we would do, the difference would be 7 minus 2 equals 5. This is our horizontal change. You could do 2 minus 7 equals negative 5. And the reason for that is it really won't matter, because if you think about your Pythagorean theorem, remember we take that horizontal distance, that's a leg, we take that leg and we square it. And when we square a positive number, the answer is positive. When we square a negative number, the answer is negative. So this would be 5 squared when we plug it into the Pythagorean theorem, which would give us 25 no matter if it's positive or negative. So it doesn't matter which x value you start with. I always start with one that will not make me have to subtract negatives, so I don't have to deal with that. So either way, it doesn't matter which x value you start with. You're still going to get 5. So let's back up for a minute. So we know that our horizontal change is 5. So let's go ahead and find our vertical change. We are again, if you have it plotted, you can literally just count 1, 2, 3, 4, 5. Our vertical change is also 5, but if you just have the ordered pairs and you're just finding the distance between those 2 pairs, you can do 8 minus 3, and subtract those y values to get 5. So now we have 2 legs, and we're trying to find the distance between point 1 and point 2. And we already know that we could use the Pythagorean theorem, a squared plus b squared equals c squared. So we have 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. I'm out of a room, so I'm just going to go right up here to finish it up. So we've got 50 equals c squared. We're going to find the square root of both sides, so we just get that diagonal distance and not the c squared of the diagonal distance. So we have 50, and we're finding the square root of 50, which is approximately 7 7/700. Now, when I show you the actual formula for finding the distance between 2 points, it looks very different. But I'm going to show you how, even though it looks different, it really is the exact same formula. So before we look at the actual formula for the distance formula, let's take a minute and copy this example into our notes. So let's label, before I have you guys do that, I'm going to label this right here my horizontal distance, and this my vertical distance. So when you go back into your notes, you see what we're doing to get those numbers. So let's pause the video now and copy this into our notes. So here is our distance formula, and every time my kids see this, they panic. They think, oh my gosh, Miss Dunn, we have to memorize another formula. But this formula is the Pythagorean theorem slightly altered. So right here, this x2 minus x1, I just showed you is finding your horizontal change. So this is going to give you your horizontal leg. So this is just another way of saying a squared. But if we don't know that horizontal distance, we find it by doing x squared minus x1, x2 minus x1, or x1 minus x2. Remember, that order doesn't matter because we're finding a negative or a positive, and it's still going to square and give us a whole number that's positive. So then here, this is the same as saying your vertical distance or your other leg. But we don't know what those legs are. So instead of calling them legs, we call them horizontal and vertical distance. So we find the horizontal distance, which is a squared. We find the vertical difference, which is b squared. So this so far is the same. The only thing that might throw you off a little bit is this radical sign that the whole thing is over top of. So we know that really we don't have d here, we have c squared. And c represents our hypotenuse. But we're doing the distance formula because we're finding the distance between 2 points. So instead of using c, we're going to change that to d squared. And we know that when we are using the Pythagorean theorem and we're plugging numbers into Pythagorean theorem, the last step to finding d by itself is to square both sides. So all they're doing is squaring the formula to get rid of the squared in the beginning. So instead of having d squared, our formula has just distance, just the side length, and it's squared the entire right side, which is our final step in our formula anyways. So even though this formula looks very different, it is the exact same thing we've been doing and the exact same thing I did on the previous slide. Without you even knowing this formula, you could have solved it before. It's a lot easier when the 2 points are on the coordinate plane because you don't have to worry about subtracting the x values or the y values. You can just count the horizontal distance and the vertical distance and square them like they're legs of a triangle. Unfortunately, sometimes they give it to you on a coordinate plane, and sometimes they just give you the ordered pairs. So how can you do it? You can plot them on the coordinate plane, or you can just remember that you can subtract the x values to find the horizontal distance, and then subtract the y values to find the vertical distance. So this is your distance formula. Let's pause the video here and get this copied into your notes, and then we'll do a couple practice problems together. So let's start with a couple examples. We are not practicing yet on our desk. I'm going to work out a couple examples, and then we'll do a couple examples together where we are actually doing guided practice on our desk. So here we are given 2 points, -3, -5, and -4, 2. And we are asked to find the distance between these 2 points on the coordinate plane. Because these points are not already plotted on the coordinate plane, I can't count horizontal distance and vertical distance to get those legs, so I would need to subtract my x and y values to get the legs. So this is x and this is y, and this is x and this is y. And you can label this x1, y1, x2, y2, but as long as you have 2 x's, it doesn't matter which one you start with, so it doesn't matter which one's x1 or x2. So we're going to start by finding the difference between our x values, which is our horizontal distance. So I'm just going to do -3 minus -4, and we know that that's the same as -3 plus 4, which is equal to 1, and that's squared. And then we're going to find, so that's this part of the formula, and then we're going to find our vertical distance, which is y2. So I'm just going to start with -5 minus 2. That gives me -7. And then we're going to square that, which is 49 plus 1. So my distance is the square root of 49 plus 1, or the square root of 50. So the square root of 50 is approximately 7 7/7. So pause the video and get this example copied into your notes. So let's look at a second example. If you do not have the formula for distance formula, or if you need that and you haven't gotten the basic concept memorized of what to do, I would have that right in front of you as you're working out these different problems. But I'm going to start by just labeling my x and y values for both of my ordered pairs. I know that I have to find the difference between my x values and my y values to find my 2 legs. So let's start with the difference between my x values, 0 minus -5. And you could do -5 minus 0. One is going to be +5 and one's going to be -5. And then we have to square that. So 5 is 1 leg and we're going to square that. That is my horizontal distance. My vertical distance is 7 minus 3, and you could do 3 minus 7. It's just going to be negative or positive, but the final answer will be the same. 7 minus 3 is 4, and we're going to square that. So we have 25 plus 16, which is 41. We have the square root of 41, which is approximately 6 4/10. So there you go, guys. You see, I didn't write the formula out, but I understand the different parts of the formula. So I start with finding my horizontal, the difference between my x, vertical, distance between my y, squaring them, adding them, and then finding the square root of those 2 legs to get the distance between the 2 points. Pause the video and copy this second example into your notes. All right, let's go ahead and look at one more example together before we do some guided practice. So again, I'm going to start by labeling my x and my y. And then I'm going to find my horizontal distance by subtracting my x values. So I have -2 minus 0, which is -2. And we're going to square that horizontal distance. Then I'm going to subtract my y values to get my vertical distance, which is -5 minus -9, which is -14 squared. Again, order doesn't matter because I could have gotten +2 if I did 0 minus -2, or I could have gotten +14 if I had done 9 minus -5. So 14 squared is 196, negative or positive. -2 squared is 4, negative or positive. So then we're going to add 4 plus 196 and square root that. So we have the square root of 200, which is approximately 14 and 1400ths. Okay, guys, let's get this last example copied into our notes and then get your socks and markers out so we can do some guided practice on our desks. Pause the video and copy this into your notes. All right, guys, let's do some guided practice. Let's start with number 1. If you have not already, go ahead and get your socks and markers out so that we can do some problems on our desk. And then pause the video and try number 1 on your desk. All right, so hopefully most of you have gotten a chance to try number 1, and let's go ahead and try and work it out together. Let's start by labeling x and y for both of our ordered pairs. We're going to find the distance between our x values. So I'm going to do 6 minus 9, which is negative 3 squared. And then I'm going to do my y values, which is 4 minus 8, which is negative 4 squared. So I have 9 plus 16, which is the square root of 25, which is not approximately, because 25 is a perfect square root, which is 5. No rounding to the nearest tenth necessary on that problem. Hopefully we all got that one, but if not, we're going to try another one. So go ahead and pause the video and try number 2 on your desk. All right, let's do our labeling first. So let's label x and y. Let's find the distance between our x values. So I'm going to do 0 minus negative 4, which is the same as 0 plus 4, which is 4 squared. And then I'm going to do 5 minus 2, which is 3 squared. So I have literally the exact same problem and answer that I have for number 1. How interesting is that? Didn't notice that, but hopefully you guys did as you were working them out. They are different ordered pairs, so if you did the math incorrectly, you may not have gotten the same exact answer, but it is 16 plus 9, and we are finding the square root of 25, which again is a perfect square root of 5. Hopefully we get a different answer for number 3. Go ahead and pause the video and try number 3 on your desk. So just like in the previous problems, we're going to start by labeling x and y. We're going to find the difference between our x values. So we've got negative 6 minus 2, which is negative 8 squared. Then we're going to find the difference between our y values. 4 minus negative 6, which is the same as 4 plus 6, which is 10 squared. So we have 64. 8 squared is 64, plus 10 squared is 100. So we have the square root of 164, which is approximately 12 and 8/10. Pause the video and try number 4 on your desk. So just like with all the other problems, we're going to start by labeling x and y. Then we're going to find the distance between our x. So we're going to do 0 minus 4, which is negative 4 squared. Then we're going to find the distance between our y. So we're going to do 8 minus 0, which is negative 8 squared. So we have negative 4 squared, which is 16, plus negative 8 squared, which is 64. 64 plus 16 equals 80. And then we have the square root of 80, which is 8 and 9/10, rounded to the nearest tenth. Pause the video and try number 5. So if we're going to label x and y, we're going to start by finding the distance between our y values. So I've got negative 1 minus negative 3, which is the same as negative 1 plus 3, which is 2 squared. Let's find the distance between our y values. We have -7 minus -5, which is the same as -7 plus 5, which is -2 squared. So we have 4 plus 4, which is the square root of 8. 8 square rooted is approximately 2 8/10 rounded to the nearest tenth. Hopefully we are all doing wonderful. I've got a couple more practice problems for you to try if you've just started getting the hang of it or you just want to make sure that you have the hang of it. So before we stop for the day, let's try 2 more problems. So let's pause the video and try number 6 on your desk. So hopefully we've all gotten a chance to try number 6. So we're going to start by labeling x and y. We are going to find the distance between our x values. So I'm going to do 4 minus -9, which is the same as 4 plus 9, which is 13 squared. And I'm going to do the difference between my y values, which is 0 minus 7, which is -7 squared. 13 squared is 169. 7 squared is 49. 49 plus 169 is 218. We're going to find the square root of that, which is 14 8/10 rounded to the nearest tenth. If you wrote 14 7/10, we need to be careful with rounding and paying attention to the tenths place as our final answer because that is what the directions told us to do. We did have to round this one up from 7/10 to 8/10. All right, guys, one more practice problem. Go ahead and pause the video and try number 7 on your desk. So for number 7, again, we are labeling x and y. Finding the distance between our x, 1 minus 6 is -5 squared. Finding the distance between our y, 9 minus 3, which is 6 squared. We have 25 plus 36, which is 61. The square root of 61 is approximately 7 8/10. And that is the distance formula. You guys will get a little bit more practice working on the distance formula tomorrow and maybe even possibly later this week. I hope you guys are getting the hang of this. It's pretty simple, especially if you understand how the distance formula relates to the Pythagorean theorem.